Hey everybody, it's Mr. Rohde. We're looking to start introducing you to the next ideas as we move forward with distance learning. Again, we know it's not going to be perfect, but I appreciate you engaging and giving this a try. I'll start to include little fun pictures here from time and time again just to hopefully remind you that we're all in this together and keep going. So hopefully you enjoy my little Bitmoji of me, and so we can pick it up from here. Our hope is to introduce you to the idea of graphing rational functions, kind of get into our daily homework routine a little bit, but know that it'll be different. I'll encourage you to pause this video at different times to try stuff on yourself like I would during class, and then you can pick it up right from where we left off with the pause to double check your answers and really engage in that process. So that's important to try it on your own, then check it against the video and be able to go back and forth. Definitely email me or message me through Schoology with any questions that come up, and we'll do the best we can. If we find that we want to do some type of live Google Hangout or Schoology conference session for live questions, we'll figure that out later, but we'll start with this. So I'm going to go ahead and hit pause, and we'll pick it up here in a second. The next thing you'll do is try to find page 443, whether in a paper book or in your PDF notes on Notability. Go ahead and take a few minutes to just read through what this embedded assessment asks. This is kind of where we're trying to get to over the next couple of weeks. And it's okay if there's unfamiliar stuff. We're going to write down those goals onto our word wall. Again, what you could do is download a blank word wall on Schoology to be able to follow along and add important takeaways as we go. So now that you've read through that embedded assessment, here are the goals that hopefully you saw that we're going to be trying to work on over time. We won't cover all these today, but to kind of give you a sense of where we're going. You're going to be writing polynomial functions again, mostly linear. You're going to be creating tables from data, writing rational functions from that data or from the graph or from word situations. Often that's going to involve understanding things like the asymptotes, like we'll see later. We're going to graph those rational functions as well. So how do we find their important characteristics? We're going to write and use variation equations, which are similar to rational functions in that the variable can be in the denominator. That's the key descriptor, right? The variable is in both the denominator, most important, but it could be in the numerator and the denominator. We're going to describe transformations of the original, most basic rational function, which is 1 over x. And we're going to identify all the characteristics that make up these rational functions. So asymptotes, both vertical asymptotes and horizontal asymptotes, domain, range, x-intercepts and y-intercepts, and how to find all of those important pieces. So here we are at the start of lesson 27.2. It's on page 421 of the paper text, or you'll have to scroll through the Unit 5 notes that you've downloaded into Notability. I've made a couple of key pieces over here on the right that you'll see here with the fixed costs and meals from lesson 27.1 that we did a long time ago to help us there. So as we look at these pieces, we're going to be formulating rational equations that model real-world situations, and then we're going to graph those equations on coordinate axes. It's kind of nice to be dealing with a concrete example instead of alphabet soup of just simplifying the expressions we just came out of. So this particular section picks up with the summer camp that we saw in a previous section. And so if you read through the problems, it says now they want to award scholarships to students who could not afford the camp. So these students would not need to pay to cover the fixed costs or pay to cover their meals. They want to give those away completely free. So we're going to look at this data, create a table, and graph it. So what I'm going to do is show you how the first column gets filled out, and then from there you can pause the video, try to fill out the rest yourself, as well as the graph below, and then when this picks up, it will show you all that work filled out, so you can check your work as well. So the fixed cost plus the cost of meals here, that would of course be $12,000 plus 45 times 50, and so I'm going to go ahead and pause. And that comes out to $14,250 for the fixed cost plus meals. But the number of paying campers, of course, when there's only 30 scholarships, That's going to be subtracting 30, so there's only 20 paying campers. I have to divide that now over 20 instead of 50. So I just subtracted 30 from that 50, and you'll do the same along the lines. That is going to be $712.50 per camper. So pretty expensive with only 50 campers. I'm going to ask you to go ahead and pause here, calculate the rest of the table, and then when this picks back up, all of that will be filled in. Okay, so at this point, hopefully you did the calculations in the table. Notice how that pattern of 12,000 plus 45 times x, where x is the number of campers, is for the second column. The number of paying campers is going to be x minus 30 because there's 30 scholarships given away. And the fee per paying camper, we divide that cost by the paying campers. So now we're not dividing by x, we're dividing by x minus 30. I then took those points, first column and last column, 50, 712.50, and plotted them on our scale down here. Again, if you haven't done that yet, please pause, plot your points, and notice that we get this rational function curve. Slowly going through there, it appears that there's going to be some type of vertical asymptote on the left and then some type of horizontal asymptote that this is approaching. Go ahead and turn to the next page and we'll go ahead and look at what this looks like. Okay, on the next page here it asks us to write an algebraic model for the fee per paying camper as a function of the number of campers in attendance. So this is based off of our table, what we already saw. The fee, so I'll call it f of x, where x is the number of campers, is going to be that total cost, $12,000 plus $45 for the meals times each camper, all divided by x minus 30 in terms of that. We want to understand where those pieces come from so that when you get a new situation, you can write a similar function. The numerator is the total cost, right? And it is the fixed plus the meals per camper. So that's the 45 times x for those pieces. The denominator is the total number of paying campers. And again, the average fee per camper, we have to take into account that 30 of the campers are not paying anything because of the scholarship program. So is there a minimum campers fee? So if we look back at our table, it kept getting smaller and smaller and smaller. Similar to a couple of weeks ago when we introduced rational functions, the fee is probably going to be approaching whatever that $45 is. As more and more campers come, that $12,000 price just gets split over more and more campers. So at a minimum, they've got to cover that $45. And then these questions ask about, referring back to what we did a couple weeks ago in lesson 27.1, we're going to go ahead and put those on pause right now because it's a little difficult to make those connections digitally, but you could look back at those. Essentially pointing out that this is going to help create our horizontal asymptote is actually going to wind up being $45. Our vertical asymptote is going to be a little bit different. It's not going to be at 0 anymore. It's going to be at 30 because, again, we've got to have over 30 campers to even have a paying camper. So again, why is the denominator x minus 30 here? There are 30 scholarship campers. If the number of campers is 2,000, what is the fee per paying camper? They're just asking us to evaluate our function at 2,000 now. So that would be plugging in 12,000 plus 45 times 2,000, and all divided by 2,000 minus 30. Again, if you're going to use a calculator here, I'd put parentheses around that, or you could even simplify it and do it in parts. But go ahead and try that in your calculator right now. So you should have gotten $51.78 for that. If the number of campers is 25, what is the fee per paying camper? This is going to be an interesting one, right? So if I switch colors here on number 7, it's asking me to evaluate f of 25. So if I go there, 12,000 plus 45 times 25, all over 25 minus 30. Hopefully you're already seeing, I'm going to wind up dividing by a negative number here. So what does that mean? Well, my fee is negative. It really doesn't make sense. because of those scholarship pieces. So that answer, what does it tell me about the limitations of this model? It doesn't make sense if my campers are under 30. That's really the limitation between that. So as we look at this one, for number 8, given the domain and range of the function, again, within the context, so we already know it's got to be a positive number of campers. In fact, we know it's going to have to be probably above 30. So in reality, our domain is going to probably have to go, and we can only deal with whole numbers, so if it can't be 30, starting at 31 and going up to, in theory, infinity, but some type of max number of campers. And then how do we figure out our range then? Well, our range, our max cost per camper is going to be when it's 31. So what is that value at 31? We'll plug it in real quick and calculate it. So again, we can see here that if there's 31 campers, it's going to be $13,395 paid for by that one paying camper while the rest are on scholarship. That would be the absolute max for our range, while the minimum, again, is that $45 that we talked about, although we'll never get to that $45 amount, so it's going to be a parentheses on it. So $13,395 being the max. So again, we're using interval notation here, not set notation. Let's take a look at the next page to kind of wrap up this lesson. Okay, so now we want to use this function to answer some other questions and see some connections. You'll notice I brought the function with me over here on the right-hand side, and I'm going to use it to answer the questions on this page. So as we look at this together, we're looking at the weekly camper fee being $80 in question 9. If the camp charges the same amount and grants 30 scholarships, what is the minimum number of paying campers that must attend? So the fee is going to be $80, which means it's going to go in for the f of x. So the 80 is going to be on the left-hand side, and on the right-hand side, our equation is still going to be there, plus 45x all over x minus 30. So the challenge is to solve this. Thankfully, we're prepared for that by our last section. We want to clear the denominators on both sides. So we're going to multiply by that common denominator of x minus 30 on both sides. The whole point of this, remember, is that it's going to actually divide away on the right. And on the left, we're going to be able to distribute that 80. So we wind up with 80x minus 80 times 30 is going to be 2,400. And that's going to equal 12,000 plus 45x. I recommend you pause to finish solving that yourself, and then I'll reveal the answer. Okay, so hopefully you did the algebra on your own. If you need to take a look at mine on the right, you can pause. Overall, 576 campers would be needed to not lose money if the camper fee was $80 per camper. In number 10, they ask us to find the number of campers as a function of the fee for each paying camper. That is going to be basically doing the steps we just did, but we're going to be reversing or finding the inverse function. So in question 11, what's the relationship here? We're actually going to find the inverse function by switching our input from being the number of campers and our output being the fee, and we're switching the input and output, so we're finding the inverse. So again, to start that, you would start by saying y equals 12,000 plus 45x all over x minus 30, and then we are going to exchange this and exchange the x and y's, exchange the input and output. So x equals 12,000 plus 45y all over y minus 30, multiply by the common denominator, and solve for y. So let's take a moment to do that, and then you can look at my work. Okay, hopefully you tried that on your own, multiplying both sides by y minus 30. The interesting part here is you do get that x times y, and so the trick is to get all the y terms together on the left and everything else on the right. And then notice the two things with the y's, I can actually do a greatest common factor, a GCF of the y to bring that out, and divide by that parentheses x minus 45 on both sides. So as it turns out, I wind up having a rational function as the inverse of another rational function, and my vertical asymptotes and my horizontal asymptotes are going to change, or exchange places really, and that makes sense if I'm exchanging my inputs and my outputs. So this function again shows what the number of campers would be. The y is the number of campers when x is the fee. as we continue to kind of go through that. So how could we, in number 12, how could we use the table of values to check the reasonableness of our answer to item 9, that 576 campers would be there? Again, back in our table, we should see that the fees are getting closer to that $80 limit, around that 500 number. For 13, explain how you could use the reasonableness, or the answer in item 10 to check the reasonableness. So again, if the fee is $80, if I plug 80 in for x, into that y equals 12,000 plus 30x over x minus 45, the output of the number of campers should be 576 as well. And then finally, in number 14, use the model and a graphing calculator to find the minimum number that must attend camp so that you do not lose money if the weekly fee is $100. For this one, again, the fee is the output, so we're going to graph f of x. We're going to graph y equals 100, see where those intersect, and know that we have to have at least that many campers and maybe more to break even. So you can do that on your TI-84 to find the intersection, or on Desmos. I'll go do it on Desmos and then show you that picture as well. So as you can see from the graph here, those items intersect at 272.7. Since we can only have whole number of campers, we're going to need at least 273 campers to attend and break even if we charge $100 per camper to cover all of our costs. So a nice way to analyze these different pieces. So hopefully that gives you experience kind of going step by step, really exploring these rational functions. Your homework is the worksheet in Schoology. Go ahead and download that to complete it. I will post a key, and there will be the chance to just explore these situations a little bit deeper, getting really used to understanding how different situations can be modeled with these rational types of functions. Again, if you have questions, send me an email or a Schoology message, and I'll do the best I can to help. Hope you're all taking care during this time, and I look forward to seeing you again in the future. And I'll keep making these better and better videos, hopefully each week, as we get more practice with it. Feel free to let me know any suggestions you have, and I'm excited to work through this with you. Take care. Bye. See you next time.